Hey everyone, thanks for joining our monthly demo here in January. We're going to give it about 2 more minutes to let folks file in, and then we will kick off and get started. So thanks for joining, and just sit tight here for a second and we will jump in. As you join throughout this presentation, please feel free to ask questions. The Q&A, we'll have some time at the end as well, but please feel free to drop questions at the bottom here, and we will address them as they come up, or if not, please let us know at the end. All right, I see the numbers slowing down a little bit, so we'll go ahead and jump in here. Thanks all for joining today's monthly demo. We're talking today about Portworx and AWS. I'm excited to be back. I've been out on paternity leave the last few weeks, so I'm excited to be back and jumping in with you all here to talk about this today. My name is Andy Gower. I lead our partner and solutions marketing here at Portworx, and I am excited to have Bob in here today to talk about this great topic and show the demo and really go into some of the technical details about what we're doing with Portworx and AWS. Quick roadmap for today. If you haven't joined one of these before, I'm going to spend about 15 minutes or so talking about what we're doing at Portworx overall and Portworx and AWS together, and then I'll turn it over to Bhavin to show the demo and to answer some questions throughout. And as I said, feel free to ask in the question drop down here, or just raise your hand or ask questions here at the end. So with that, I'm going to get started. And the place we really like to start, going to the 50,000 foot level, is why are we here? Why is Portworx important? Why are we working with AWS? Why is Portworx something that we should care about today? And it all starts with data. It's this explosion of data that we've seen across the board that is really powering the businesses of tomorrow, and really it's powering the businesses of today. As we've seen COVID and changes in the way we transact from analog businesses to digital businesses, things like Instacart and Uber Eats and other online applications or online storefronts, the importance of data and the ability to process data quickly, the ability to stay up all the time to support those transactions has become more and more important to the businesses that are thriving in this environment. And what we know is that the businesses that are thriving, those leaders, are doing it on the top of a cloud native stack, right? They've looked around and said, the traditional stack I had doesn't quite scale with this new digital first, this new data driven approach. I need a cloud native stack that's built on a hybrid cloud infrastructure. So AWS, some on-prem, maybe a third-party cloud, using app-driven automation with things like containers and Kubernetes, and using a wide variety of data apps, not using a single database, but using open source databases, using Cassandra and Kafka and Spark and Elastic, and putting all these different things together to create a new cloud native stack that can help harness and process this data quickly and easily. And in the process, it's creating a set of new people and processes, things like DevOps and GitOps and data pipelines. And so you take all this together and you say, okay, what's really driving this forward? And it's containers and Kubernetes. It's this emergence of containers and Kubernetes as that automation engine that's allowing these apps to scale, that's allowing them to be dynamic, that's allowing them to be mobile and really support this influx of new data. So just some stats here: 95% of new apps are being developed in containers. 81% of enterprise are working with 2 or more public cloud providers. 78% of CNCF members are using Kubernetes in production, and 85% of global businesses will be running containers in production by 2025, up from 35% in 2019. So really, it is this container and Kubernetes stack together that's driving cloud native forward, that's taking it to the next level for businesses. And what we also see, and kind of narrowing our focus into today's topic, is that we also see that a lot of organizations are using AWS EKS specifically to run those containers, to run those workloads, to deploy Kubernetes in containers in production. 65% of organizations, according to a statistic we have, are choosing AWS to run their containers, and obviously that is no surprise given AWS's presence in the general public cloud marketplace. But what we see and what we know from looking at Kubernetes in general is that Kubernetes and AWS alone can't solve some key business requirements around storage for production workloads. So things like cross-AZ high availability, things like backup and disaster recovery, things like cross-region migrations, things like security and compliance management. These are areas that are really important for us to go into production, but aren't necessarily addressed or aren't completely addressed by just Kubernetes or by EKS alone. And so that's what brings us to Portworx. That's what brings us to what we are doing with AWS to help address some of these challenges or make sure that these workloads in production are successful. If you're new to Portworx, if you've not come across this before, just kind of to set the stage, we have been recognized as the gold standard for Kubernetes storage by GigaOM. We also, with our bigger pure brethren, have also been recognized as a leader in the enterprise Kubernetes storage space. So we have a lot of experience in this space, and we've done a lot and received recognition for the work we've done in this space. And we're also the most widely used Kubernetes data services platform by enterprises and SaaS companies and cloud companies. And so it's not just that we are partnering with AWS, it's that we partner with a wide variety of Kubernetes distributions, folks like Google, Red Hat, IBM, VMware, Rancher, to provide a single solution for customers who are exploring or are going into production with Kubernetes and containers. And I put this up here not to say, just say, you know, where we've been successful, but really to say, hey, we've done this with customers, big and small, different locales, different industries around the globe. And so if you have a problem or a challenge when it comes to containers and Kubernetes with AWS or with AWS and a different partner or with a different partner altogether, we have likely worked on that scenario before, and we can bring that experience to bear in all the things that we do here at Portworx. So what exactly is it that we're doing? So I'm going to talk about 3 kind of case studies with AWS, and I'm going to introduce the overall platform. So the first thing I want to focus on is cloud migration, and specifically CHG Healthcare. So CHG was looking to migrate to AWS while meeting requirements around replication, DR, and compliance. And for those of you who don't know CHG Healthcare, they are a staffing company that staffs hospitals around the country. And so for them, it's really important that they maintain things like HIPAA, that they maintain things like compliance with local regulations, with local healthcare regulations. So they wanted to move to AWS. They wanted to embrace containers and Kubernetes, and they needed a way to easily do that. So by using Portworx Enterprise on top of EBS, they're able to move those workloads to AWS and provide the replication, the DR, and the HA that they were looking for in order to satisfy their core requirements from a compliance standpoint and from a business requirement standpoint. And along the way, they accelerated their cloud development lifecycle, and they reduced their monthly data streaming and management costs by $5,000. So this is kind of the first place where we come in and can work with AWS. I'm looking to migrate from another cloud. I'm looking to migrate from on-prem. I'm looking to migrate whatever it is to AWS. I need those core requirements, and Portworx can help make that happen. The next case study, or the next kind of use case where we see a lot of overlap, a lot of work with AWS is backup and restore. So one thing we know is that being online and being able to respond to offline scenarios or to back up for compliance reasons or restore for compliance reasons is critical in today's age. We hear stories all the time about availability zones going down or ransomware attacks or other things that make our lives difficult or make it difficult for us to be up and running. And so with Portworx, working with EFS, working with EBS, working with S3, working with EKS, we're able to provide a single click backup and restore for any Kubernetes application running on AWS. And this can be running on EKS, this could be running on another Kubernetes platform on top of AWS. And we're able to provide container granular app-aware backup and restore for those applications so that you can quickly and easily back up and restore to any S3 endpoint for fast recovery, and you can seamlessly back up from other databases to AWS. So you might have a database on Google or another third-party cloud, and you want to have a second backup on AWS, you want to move that back up to AWS. We're able to do that quickly and easily, again, with a single click. And we're also able to use this to provide things like zero RPO disaster recovery, right? So say you're running in AWS East 1, it goes down, you need to quickly restore so that you don't lose money, you don't lose time, you don't lose customers, whatever the case is. With our backup, with our PX Migrate, with our backup and restore capabilities, we can quickly fail you over to AWS West 2 so that your downtime is minimal and your uptime, your ability to transact is as good as it would be if East 1 didn't go down. The last one I want to talk about is Jenkins. So Jenkins is a really interesting use case that we have done a lot of work with on AWS. We have a validated design that we've done with them, or a Amazon review. I forget exactly what the terminology is, but we've worked with them closely to put together a technical document that shows how you can use Jenkins on EKS to solve some key requirements that EBS and EFS don't address. So one of the big things with Jenkins is that you need it to be highly available, you need it to be performant, and you need it to be secure. And most importantly, you need to be able to have that failover across availability zones, that HA across availability zones. Well, EBS doesn't support that natively. There's no easy way for you to do that with Jenkins and EBS. And EFS isn't suitable for those write-heavy I/O patterns that Jenkins brings to the table. So what's the solution? Well, PX Enterprise with EKS can layer across multiple availability zones on EBS so that your Jenkins deployment can have that HA it needs across availability zones, and it can provide that highly available, performant, and secure Jenkins you need for your enterprise to be up and running. So again, this is an area where we've worked with AWS to say, hey, how do we take EKS, make it better, and provide customers with a quick and easy way to have the business requirements they're looking for solved with key services like Jenkins. So the last slide I want to touch on, and then I'm going to turn this over to Bhavin, is just pulling back and looking at what is the PX Enterprise data services platform. So as I mentioned, Portworx is a Kubernetes data services platform that runs on top of any AWS region, on top of any AWS Outpost or EKS Anywhere environment, and it supports 6 key modules, including the use cases I just talked about. So things like PX Store, which provides container native storage layer, PX Backup, which does that backup and restore that I just talked about, PXDR, which provides that disaster recovery, PX Migrate, that lets you migrate between availability zones or from other clouds to AWS, or from AWS to on-prem, from EKS to an outpost, whatever the scenario is, PX Secure, which provides that BYO encryption, the encryption at rest, the encryption in flight, and also role-based access control, and PX Autopilot that lets you smartly scale so that you pay as you need it. You don't pay up front and overpay for the amount of cloud storage we use. And we support any app. So any Kubernetes app, any database, any streaming platform, any search tool, AI, ML, we provide this single comprehensive data services platform on top of AWS. Okay, so that was a lot. I know that you guys are mostly here for the demo. That's the key part. I want to get it over to Bhavin. Just quickly, again, what did we talk about? Key things, Portworx on AWS at a glance that we can provide, cross-AZ HA, backup and DR, cross-region migration, and optimizing infrastructure with PX Autopilot. This is really where Portworx can bring value to the table and help take an AWS deployment and make it even better, make it even more effective for your enterprise. Okay, so Bhavin, I'm going to turn it over to you. I just want to flash this up for 1 second before you get started. We do have 3 ways folks can get started. The easiest is actually this one here at the bottom. We have a 30% offer that exists today on AWS. You can get it at this link here. You can go to the AWS Marketplace to try PX Enterprise or PX Backup on its own. We also, through our own website, offer a forever free version, Portworx Essentials, a 30-day free trial of Portworx Enterprise, and a 30-day free trial of just the backup capability itself. So with that, Bhavin, I will turn it over to you to get to the meat of things and really dive into the technical side and the demo here.
Awesome, thanks, Andy. Let me mess with GoToWebinar so I can share my screen. And let me know if you can see a terminal window now.
Yes, we can see it.
Okay, perfect. Let me move this video screen. Okay, perfect. So hello everyone, Bhavin Shah. I'm a technical marketing manager with Portworx, or with the CNBU at Pure Storage. And in this demo part of the presentation, we'll be reinforcing the message that Andy already spoke about, right? So we spoke about how you can ensure resiliency and fault tolerance against different levels of failure events and outages, which might lead to application downtime. And application downtime is not something that we want. So based on your service level agreements or SLAs that you have defined with your application owners, we'll talk about what are the different solutions that you can leverage to ensure that even if you like get hit by an outage, you don't remain offline for a longer time. So starting from like all the way on the left side of the spectrum, where you can avoid, you can handle some form of outage. Yeah, it's okay to have some RTO and RPO and RTO specification, and you can bring your applications online in a different cloud or in a different region in AWS. You can use PX Backup, because PX Backup, being that data protection tool, can talk to your EKS cluster, and it can help protect all the different Kubernetes objects and your application configuration and the data, and store it in an S3 bucket. So in case of a cluster failure, in case of a region going down, you can use the backup snapshot that's stored in S3 and restore it to a completely brand new EKS cluster if that's what you want. And for this combination to work, the Portworx Enterprise layer as the Kubernetes storage layer is completely optional. You can choose to have Portworx Enterprise, and obviously there are benefits to doing that. But if you just want to consume EBS as the storage layer for Amazon EKS, you can do that and just use PX Backup for your backup and restore needs. So that's one scenario. Second scenario, that's the live demo that we look at in this presentation, is around AZ fault tolerance. So you can have an EKS cluster with individual worker nodes spread across individual AZs. And we have one such cluster here. So if you do a kubectl get nodes -oy, you will see that all of our nodes are actually running in a different AWS region, different AWS availability zone in the US East 1 region. So here I can have different Kubernetes worker nodes that eventually form that Portworx enterprise layer. And in case of an AZ failure, something going wrong with a specific set of racks in an AWS region, your application doesn't suffer a longer downtime. It can quickly come back online as soon as possible. So we'll see how it differs from the way AWS does things with EBS, and how Portworx can benefit you or give you additional advantage. And then the remaining two pieces are more of recorded demos, and we'll go through both if we have the time. But they are around setting up those disaster recovery solutions using Portworx PXDR that Andy highlighted. So you have your asynchronous disaster recovery solutions, so where you can achieve region level fault tolerance. So if US East 1 goes down, you can already have DR solutions in place, where if the region goes down, your primary EKS cluster goes down, you can log into your secondary EKS cluster, just execute a simple command, activate a migration, and start bringing your applications back online. And then the last scenario, and this is one of our customer stories that we didn't mention or highlight today, is around synchronous disaster recovery solutions. So if your applications can't suffer any outage, can't suffer any data loss, you can use Portworx PXDR to create those sync DR solutions, where any write that's handled by the primary EKS cluster automatically gets transferred and written to on the secondary cluster before the write is acknowledged back to the application layer. So you have a synchronous DR replication for any data that's written on your primary side. So if your primary cluster goes down, you can log into your secondary cluster. All your persistent volumes are already there with all the data that's ever being written, and you can just start bringing up those Kubernetes pods and deployment objects and start bringing your application online. So 0 RPO and then a few seconds of RTO time. So let's go through these scenarios. We have one live and two recorded demos, just to make sure that we are able to cover more ground in this specific monthly demo session. So the scenario that we are doing live is one where we have a 5-node EKS cluster. And these 5 nodes are each running in different availability zone in US East 1. We already have Portworx deployed. So if we do a kubectl get pods in the kube system namespace, you see that we have Portworx that's already up and running. And we can exec into the pod to get more details around it. So if I exec into it, and let me know on chat if the font is not readable, and I'll zoom in, zoom out and do the necessary. We can use the pixie-cutter utility that's installed inside the Portworx container. And then if we just do a status, here you can see that we have a Portworx cluster, which is completely operational. I deployed this a few days back, 3 days back. We have that free 30-day trial license that Andy referred to. And then each of the 5 EKS worker nodes is contributing 150 gigs of storage to my overall Portworx storage layer. And this is where, like, once you have this Portworx storage pool configured, you can define individual Kubernetes storage classes to create read-write once, read-write many, so block and file storage classes, and enable dynamic provisioning of those persistent volumes for your developers and for your pods that need persistent storage. We can also execute additional commands like volume list. So this basically gives you a list of all the persistent volumes that are running on your Portworx cluster, basically on my EKS cluster. As you can see right now, I only have one persistent volume running. And if I use the command volume inspect, and I use the volume ID for that specific volume, you can see, and like you can get more details around it. So we have a size of 10 gig persistent volume formatted with ext4. We have a high availability enabled. So the storage class that was used to dynamically provision this volume had a replication factor set to 2. So any data that's written from my application pod for this read write once volume gets copied to 2 different replicas that are stored on the EKS cluster. So if we scroll down, I can see that, okay, there are 2 nodes in my EKS cluster that host this particular persistent volume, or host the data that's being stored in this persistent volume. So if I exit out of the Portworx pod and I look at my demo application that we have deployed for this monthly demo, we have a simple UI-based application. It's a web-based application. Let me just navigate to it, where you can basically, whenever you click on the screen, it generates a Kubernetes logo. On the back end, it basically translates into a new database record that's stored in a Postgres database. So we have an application that's up and running. We have, the application consists of 2 deployment objects, couple of service objects, a couple of pods, one pod mapping to each deployment object, and replica set. If I do a kubectl get PVC in the demo namespace, you can see the persistent volume that we looked from the Portworx perspective is running in the demo namespace, which is attached to our Postgres pod and storing all the database entries that we generate using the UI. So if I want to simulate a AZ failure in this particular EKS cluster, what I can do is I can just go ahead and identify the node where Postgres is running, and then basically kill that node using the AWS console. So that's what we'll do. If I do a kubectl get pods in the demo namespace and do a dash or wide, here I can see that the Postgres pod is actually running on 192.168.58.50, which is the internal IP for one of the EKS nodes. If I scroll up and if I look at the replicas for the persistent volumes that are stored, you can see that one of those replicas are co-located on the same EKS worker node. So 58.50 is our worker node in question. So you can see that one replica is hosted locally. And this is also something that Portworx brings to the table. So we have our storage orchestrator for Kubernetes called Stork that works with any Kubernetes distribution. And whenever a pod requests for a persistent volume claim, when we work on provisioning the PVC and provisioning the pod, we'll make sure that both of those get provisioned on the same node. So there is data locality and you get the best performance out of it rather than having to go across AZs to read and write data. So one copy is always co-located on the same EKS node that's hosting the pod. So what I want to demo in this use case, or in this scenario, is we'll log into our AWS Management Console, identify the node. So the IP that we are looking for is 58.50. So this is basically the node that's hosting the pod and the persistent volume claim. I'll just terminate the instance without any graceful shutdowns, without anything. So at this point, Kubernetes, like the checks that Kubernetes API server runs against the worker node pool, it will identify that, okay, the desired state that I had configured as part of my EKS cluster was 5 worker nodes. One of them is down, so it will take that out of commission, and it will start provisioning a new node. At the same time, the Kubernetes objects that are hosted on that particular pod, like the Kubernetes pod and Kubernetes persistent volume for our application, will also get restarted. So Kubernetes will restart the pod on the new node, and because of Stork, it will provision the pod on the node that already has a copy or a replica of our persistent volume. So this avoids any application downtime. It basically, as soon as the pod is restarted, it gets deployed on the second node which had a replica, and you get access to your data as soon as possible. So this is different from, so I have a simple script which basically, as soon as the Postgres pod is online, it restarts the front end pod as well and brings the application back online. So let's wait for this. There's a small sleep timer associated with it. But while we wait for the deployment to be done, the scenario, if you're not using Portworx, right, what would happen is, and I actually tested this before this demo, the scenario is, okay, you have EKS worker nodes, you have EBS volumes that are attached to it that might be in one or different AZs. If the AZ which is hosting your EBS volume and your EKS worker goes down, you lose access to data if you don't have snapshots or backups taken. But even if you have your EBS volume and you lose the EKS worker node that's mounting that EBS volume, your node will go down. EKS will have to spin up a new worker node as part of the EKS worker node pool. And once the node is fully up and running, that's when the EBS volume will try to be reattached to the new node, and then bringing your persistent volumes online. So this, even for a single PV and a single pod, took me 4.5 minutes. Whereas in case of Portworx, as soon as the new, as soon as your EKS worker node was deleted or your AZ availability zone went offline, the Kubernetes will restart the Postgres pod on a new node which already has the replica. So think about the difference in the amount of downtime that you have, from minutes to just a few seconds, and you will have your application back online. So that's how easy it is to design a solution which can tolerate availability zone outages. But in this case, you're not creating a secondary cluster, you're not paying for any additional tools and resources. This is something that comes out of the box using Portworx, and you can use different topology awareness based deployment models for your applications that are running on EKS. So now that our script has returned, we'll do a kubectl get pods again. You can see, in the demo namespace, you can see both of our pods are now up and running. If we do a get pods -o wide, again, you can see the Postgres pod is now running on 74.218. If I scroll up, you can, like our original second replica for our persistent volume was hosted on 74.218. So because of the intelligent orchestration and provisioning of Kubernetes objects using Stork, we provisioned it to a node that already hosted a replica. So your application downtime was eliminated. And if we go back to the UI, right, and if you refresh the page, your application is already online. You can keep using it, continue adding more records to your application. So this is how easy it is to build a solution using Kubernetes that's resilient and fault tolerant and robust. So that's just the first scenario. Next, again, if you have questions, start putting those in chat or in the questions pane, and we'll get to it in the last 10 minutes of the session. I want to use the time that we have remaining for 2 different demos. So as I said, like one of them was a live demo, the other 2 are recorded demos. So we'll walk through different scenarios. So here we have a synchronous DR disaster recovery solution for Amazon EKS. And what we have done is we have built a sync DR solution across 2 Amazon EKS cluster. So on the left, we have our primary EKS cluster. On the right, we have our secondary, and then across these two EKS clusters, we have a single stretched Portworx storage cluster. So this basically means that whenever I am creating a persistent volume, it's creating a volume on Portworx layer, and then it's creating a replica on the secondary cluster. So any data that's written, it's automatically copied on the secondary side. So if my primary side goes down or my primary EKS cluster goes down, my secondary EKS cluster is already there with all the data present. All I need to do is activate the migration, so it will deploy my application pod. So let's go and look at some CLI instead of just an architecture diagram. So here we have two clusters.
Hey, Bob, yeah? A quick question for you as you talk through this from the chat. Space constraints. Are there any limitations in terms of how much data, how big the node can be? What are the size or space constraints for any of these use cases you're talking about?
Gotcha. So there is no there are no space constraints for when it comes to Portworx. If we go back to our live cluster, we can look at this in detail. So if I exec into the Portworx storage pod and look at the status again, you will see that each worker node is basically attaching an EBS volume as a Portworx storage disk. And then we aggregate all of those individual disks, so 5 in this case, into a single unified storage pool. And this is just the starting scenario. You can have as many EBS volumes attached to each worker node as possible, like as much as AWS allows you. With the GP2 does have some restrictions. I think it's 25 EBS volumes per EKS worker or per EC2 instance, so that might still apply, but the size, there is no limitation. And from a Portworx perspective, we don't care. Like as much as storage you can provide, we'll aggregate that and present it as a unified storage pool for your applications to consume. So that's one case, that's day 0. But let's say you started with a scenario where we have 750 gigs of storage, right? And on day 2, even without any admin intervention, you want your EKS cluster and the Portworx storage cluster that's running on top to expand as needed. And that's another module that Andy listed earlier, right? PX Autopilot. So in that scenario, as a DevOps admin, as a cloud admin, what you can do is you can create autopilot rules which are basically if this and that rule. So if your persistent volume goes above 50% or 70% utilization, just double the size of the persistent volume. You can have this policy in place. A second example of a policy in place is if my Portworx storage pool, the 750 gigs that that I see here, if that gets full, like if that's reaching a point where it crossed the 600 gig mark, I know I need to add more storage. So you can have a rule in place where it says monitor my storage pool. If it goes above 600 gigs, add more storage to the pool automatically. So on the backend, what Portworx will do is it will talk to your EKS cluster. It will provision those additional EBS volumes, attach it to your EKS worker nodes, and expand the Portworx storage pool that's available to you. So without any admin intervention, you can automate all of these processes. So not just persistent volume expansion, but also the underlying Portworx storage pool expansion for your Kubernetes stateful applications that are running on EKS. So I hope that helped answer the question. Okay, so as part of SyncDR demo, we have 2 clusters. The one on the blue is our primary cluster that's hosting our applications right now, and we know something is going to go wrong with it because the green cluster is our secondary cluster, and green will make sure that everything works at the end. So both of these are identical clusters that are running in I think in the same AWS region, if I remember correctly. This was a few days back. The only requirement we have from a synchronous disaster recovery solution perspective is that you should be able to meet the 10 millisecond round trip latency requirement. As long as you can do that, you can have these clusters in the same AZ, different AZs, different regions. If you can have that. I think I tested this with the same region, different AZs. So I have 2 EKS clusters. One is both of those have 1 master and 3 worker nodes running Kubernetes version 1.21. And let's look at a couple of additional things. So if I SSH into one of the nodes, I can run pixie-curl commands against it. So here you can see if I do a pixie-curl status, again it's the same thing. Like Portworx is running. Every node in the cluster is contributing storage to it, storage to our Portworx storage pool, and in synchronous DR configuration, we have different cluster domains where there will be site A or primary cluster domain, and then site B, which is our secondary cluster domain. So you have those two cluster domains configured, and you have nodes from both the EKS clusters that contribute storage to it. So if I go ahead and look at the application that is deployed for the demo. So if it's a different application this time. It's a simple pet clinic application. I think it's built using Spring. Again, it has a front end UI that you can interact with, and then we'll fail it over from the primary to the secondary cluster. It has one single persistent volume claim, which is storing the data that's written in our MySQL database, and it has a size of 8 gigs, and it's also a read write once, and it's using a px REPL2 storage class that dynamically provisions that persistent volume for us. So we can use the node port IP, like the node IP and the port and access our application. We'll perform a few applications, read operations. We'll also perform some write operations just to make sure that our application is up and running. So you can interact with the application, and this is not something that we'll just show pod failures, but this is an actual application that's running on EKS. So next, instead of focusing too much on the application, let's come back to our CLI interface, and we'll go ahead and perform a failover operation. So in this case, what we'll do is you can do a kubectl get cluster pair. So cluster pair is the trust object that's created between our primary and the secondary cluster. This is what enables Portworx to copy all the persistent volumes and all the Kubernetes objects from our source to the destination cluster. And you can then define, once you have these relationships, you can define migration schedules. So migration schedules help you. So let's take a step back. For syncdr, your data is automatically getting copied from the primary to the secondary cluster. Yes, but I still need to copy my Kubernetes objects if I want my recovery plan to work. So that's where you can use a migration schedule object to specify all the different resources that should be part of the individual migrations. So we have a migration schedule called app migration schedule that basically leverages the same cluster pair and a schedule policy, and it copies objects from our source to our destination site. So next, if we use like a different command like a starkctl get migrations in the same namespace, you will see that at a specific time interval that's defined by the policy name, by the schedule policy, the migration operation is performed between the primary and the secondary site. In this case, the data is copied. We are just copying 6 Kubernetes resources from primary to the secondary. And the schedule policy is also something that you can configure to meet your own SLA requirements. Here in the app schedule policy, we use a time interval of 2 minutes. But again, that's completely customizable from an admin perspective as well, based on the SLAs that you have. Now let's go ahead and look at the application that's deployed. So it's in our default namespace, not a different demo namespace like the previous demo. What we need to do is we'll do a get migrations, confirm that it's running and it has been successful. In order to simulate a failure, I need to suspend the migration. But again, if this was a real failure event, you won't even have access to your primary cluster. You can just log into your secondary cluster and activate that migration. Since this is a simulation, we'll set the suspend flag to true. So when we scale down the application on the primary side by using the kubectl edit replica count for our deployment objects, we don't accidentally transmit the same information to the secondary side. So that's the reason of suspending the migration schedule. So now let's go ahead and scale down our application. So we use the kubectl scale command. We'll start with the backend, set replica count to 0, and then do the same thing over for our front end deployment object as well. So once our pods are terminated, we can go to the secondary cluster and start bringing those applications online. So one of the things to note here is, as part of each migration, that's part of a migration schedule, Portworx will copy the Kubernetes objects, but it won't spin up any pods. This is to avoid any application inconsistencies. You don't want your application pods to be online on 2 different sites at the same time. So that's why when we do a kubectl get all on the secondary cluster, you won't see any active pods. You'll see the deployment objects with their replica count set to 0, like we see here. but you won't see any pods. So you'll see deployments, you'll see service objects, you'll see the persistent volume, but you won't see any pods. This is the pods will be spun up when we actually go ahead and activate the migration. So we'll before we activate the migration, we'll deactivate the cluster domain, which is the primary side, just to make sure that no new data gets copied over. And once that's done, we'll confirm that the primary side is no longer in sync. It's the secondary side that holds the primary copy of our data. So that's where we are. And this is the simple command that you need: *ctl activate migrations. And this is a namespaced object. So if you have multiple applications running in different namespaces that are copied from your primary to secondary side, you can use the same command with a different namespace to bring all of those online. So at this point, you can see that our pods are getting spun up for our deployment object. So it basically scaled the replica count to match the value that we had configured at the primary side. So our pods go through, like, obviously our backend pod needed to come first for our front end pod to have connection. So that's why it went through an error state. But now once our MySQL pod is up and running, our front-end pod will come online as well, and we'll be able to access the same application and ensure that our application has successfully recovered from a failure of our primary EKS cluster. So this is how easy it is for synchronous DR solutions, where you don't have any form of data loss and a really low time to recover from an outage or from a disaster event. Let's see what the time is. Okay, we have 15 or 18 minutes at this point. I have one more demo, but let's see if we have any more questions, Andy. If not, okay.
Yeah, I keep on going. I don't see any in the chat, but folks, feel free to drop them in, and I will grab them, and I'll keep going on this, and we'll circle back.
Awesome, thanks, Andy. Okay, so this last scenario is our asynchronous DR solution. So not all applications that you have running on EKS need that 0 RPO or recovery point objective, because deploying 0 RPO solutions needs more resources. Here you can have an async DR solution using Portworx PXDR, where your primary cluster can exist in US East 1 and your secondary cluster can exist in US West 2, for example. And unlike how the requirement that we had for synchronous DR, where we needed that 10 millisecond latency requirement, that requirement doesn't exist for async DR. For async DR, you can have clusters that are in completely different regions, as long as they can talk to each other, like there's some form of network connectivity. Portworx will be able to build that cluster pair relationship between your primary and secondary cluster and perform async DR replication between your primary and secondary cluster, again using a schedule policy that you define as an admin. So you have complete control over how your applications are copied from the primary to the secondary side. Here the writes that come in at the primary side aren't immediately copied to the secondary side. They will be copied at the time interval that you choose. So if you set an SLA requirement or a schedule policy for 15 minutes, that's your RPO. So every 15 minutes, Portworx will copy anything that's written on your primary side and copy it over to your secondary side. And in case of a disaster, that's when we'll spin up those application pods once we activate the migration. So that's again the slideware. Let's go ahead and look at a couple of CLI things as well. So we have similar 2 clusters, the blue cluster, which is the primary cluster right now. This time it's a 6-node cluster, and then the green cluster, 6-node cluster, but running in a completely different region. We can go ahead and look at Portworx, which is already up and running on both sides, and it's ready for our async DR demo. We can use the same commands on the secondary cluster and verify that everything looks good. So kubectl get nodes. You can see we have 6 nodes again in US West 2 running Kubernetes version 1.20.11. If we do a kubectl get pods in kube system namespace, you will see that we have Portworx running on the secondary cluster as well. So Portworx is deployed on both clusters. We are ready for our DR demo. So if we do a get all in the demo namespace, here we have a third application. In this case, I chose WordPress as our application or demo application of choice. And you can access the WordPress front end using an ELB endpoint. In this case, we have 2 persistent volume claims, one for MySQL and one for the front-end WordPress pod as well in the demo namespace. And we have a secret that's defined as well. So in not just deployments, pods, and service objects, Portworx can handle secrets and persistent volumes in any Kubernetes objects that you have running as well. Accessing the WordPress site from using the ELB endpoint, we can look at the site. We can also add a new post just to make sure that there's new data being written that we leverage for our replication. So let me just forward through this where I generate the post. Basically, we have a new demo post which shows our application is online. New data is written to the persistent volume in the MySQL persistent volume on the backend. So now we have, let's look at our schedule policies. So if we do a kubectl get schedule policy, you see that we have a demo schedule policy already defined. Let's go ahead and apply our migration schedule, and then we look at what the YAML file for that migration schedule looks like. So once we have applied it, if I do a VI, and I'll pause here for a minute. So here you can see that we have defined migration schedule. So given it a name, which is demo migration schedule. We have defined the namespace as demo. So basically Portworx will capture everything that's running in that demo namespace and move it to the secondary cluster. It's using a cluster pair object called async_dr. It will include all resources. Let me go back quickly. Include all resources. So pods, deployment service objects, secrets, persistent volumes, everything, but it won't start applications on the secondary side. So because this is not a one-time migration, this is a continuous migration which will follow the schedule that you have specified in demo policy. So that's why our start applications flag has been set to false. So now that we have looked at the migration schedule policy, we have already applied it. So you can do a get migration schedule in the demo namespace, and you can look at the different, like you can see whether the migrations have already begun. So migration schedule is one object. You can use kubectl or storkctl to look at it, but then each migration schedule spins up a new migration object at every interval. So we can also get those. So here in this case, as soon as our first migration object was triggered, it used our cluster pair. The migration was successful. It copied both the persistent volume claims that we had on our primary site or part of our WordPress site and moved those to the secondary site, and all the nine different Kubernetes objects, pods, deployments, secrets, service objects, all of those were copied successfully from our primary to the secondary site. So next, let's go ahead and like fast forward this a bit, but we can log into our secondary cluster. We can do a kubectl get all in the demo namespace. Here you can see service and deployment and replica set objects already created. There are no pods again because we want to avoid application inconsistency, and those pods can be spun up easily when we activate the migration. If we do a get PVC, you see that we already have the two persistent volume claims that were part of our application on the primary cluster as well. So our application is now ready. Now we can do is simulate the same failure event. So we'll suspend the migration schedule on the primary cluster. Again, in the previous demo, we edited a YAML file, but there is also a single command to suspend migrations. storkctl suspend migration, the name of the migration schedule and the namespace. And once that's done, we'll go ahead and start spinning down or scaling down our application as well. So we'll use the deployment objects and then use kubectl scale commands to basically terminate the pods that are running in our demo namespace. So let's get the name of our deployments and use kubectl scale replicas, and then use WordPress MySQL and WordPress commands in the demo namespace. So this will basically delete our pods that are running on the primary side. And again, just to reiterate, like if this was an actual failure event, not just a simulation, you won't even have access to the primary site. You can just directly log into your secondary cluster and activate migration. I should have just removed this section and like spoken about EKS, the primary cluster not being available. But this is where we are. So no pods running in the demo namespace. So we can go ahead and log into our secondary cluster and activate that migration. So use that one single command called storkctl activate migrations in the demo namespace, and it will start deploying the replicas and pods for our deployment objects. And once that's done, you can basically do a get all in the demo namespace and monitor your pods being spun up. So this is how easy it is to also have an async_dr relationship, where instead of having clusters in the same region to ensure that 10 millisecond latency requirement, you can have EKS clusters that are spread across different regions, no latency requirements whatsoever, as long as they can talk to each other and you can perform failover and failback operations between two different EKS clusters. But yeah, that's it for this demo. Let me go back to my, I think I'll pass it back to Andy to flash the slides again.
Yeah, so one question, you mentioned latency there at the end. One question, what's the max latency we should expect between availability zones, whether asynchronous or synchronous?
So max latency that we can afford?
Yeah, so what's the max latency a customer would see, right? You know, in synchronous, what's the maximum they would expect, or in asynchronous, what's kind of that max latency?
So when I tested it out, right, I always got somewhere between 8 to 10 milliseconds when it was in the same region but different AZs. But if I tried different regions altogether, I wasn't able to hit the 10 millisecond requirement. So I think it might, like, the latency might differ from account to account. So like, make sure you test it before deploying the SyncDR solution.
Any other questions? Let's see. How do you resolve split brain situations?
So we do have, when we are talking about the stretched cluster solution, your application is not running. It's not an active configuration. It's active passive. So your application is only running on one side. We do have an external HCD data store database that we use for Portworx. So in SyncDR solution, since it's one stretched cluster across two EKS clusters, we use a single external HCD cluster to store the state. So the cluster state is actually stored outside. So regardless of which cluster goes down, either Portworx cluster can talk to it and bring and give you a correct state and bring your applications online. But yeah, it's not active for split brain.
Any other questions? While I wait and see if there's any more, I'm gonna just steal back the screen for 1 second. And just, you know, a reminder here on what I've mentioned, ways you can get started. So again, we do have a 30% off trial today. This link here will take you to this page where you can register. Unlimited free trial for 30 days, 30% off with no time commitments, no long-term contracts. So please check that out if you're interested. And as shown on the screen, right, we've got a couple other versions. We've got the Portworx Essentials forever free, and you can just test just the backup solution if you want to as well. And we are on the marketplace, and we do have an AWS page if you want more information. Bhavin has done a ton of really awesome videos and demos and blogs on different topics, not just this, with AWS. So if you check out the website here, you can find those, and some of them are also posted on YouTube as well. So please check those out if you have additional questions. And if not, feel free to reach out to us and you know, jump on the trial if it's something you're interested in. One last call for questions. We'll give it another minute or two, and if not, we'll call it a day here. All right. I don't see any more coming in, so we'll stop it there for today. But you know, feel free to reach out to us and join us next month. We will have another monthly demo in February. I don't think we've determined the topic yet, so if you have ideas, if you have things you want to see at future monthly demos related to AWS or other platforms or other use cases, please reach out and let us know. We'd be happy to put those on the agenda. So with that, thanks everyone for joining today, and hope you guys have a great rest of the day, and catch you on the next monthly demo.